So this is the question number 268 of Leetcode. The question states that we have given a vector that is called nums with a certain data set in a range 0 to n with a number that is probably missing. So say this is our data set, and we can clearly see that over here we have the number 4, and our task is to return this element. So there are two approaches for this solution, beginning with the brute force, that is the much more conventional method that often is first struck to mind. So now let's begin with our brute force approach. So our brute force approach is we take the nums array, we sort it, compare it with all the elements, that is goes from 0 to the size of the array using a for loop. As soon as we find an element, I say, in this range that is not existing in this sorted array, we return this I. So the code would be something like sort nums begin. That is how we mark the beginning of a sorting function, and then we write where do we like to end. After that we write our for loop that is for the range that is going to be used up. Thus the size becomes nums.size, and our updation is an increment of 1. Now we are writing the if condition that is going to be comparing this sorted array with every element in the range. So if element in I is not equal to, say, any number in the range, we return that specific number. However, since it is it is going to be under a function, we have to give something to return as well. And this is also extremely good for us because, say, for in cases such as this, that is this test case 2, where the number is given 0 and 1, we are missing 2 because the range is, so the size is of 2, and this implies the range is 0 to 2, and thus number 0, 1, 2 is to be present. However, we can clearly notice there is no 2 in this given array, and thus we will return in such case the size, because the size is going to be the last element. Thus in this case we return nums.size, and just like that we have ended our brute force approach. However, this takes a bit more time than the much more efficient code, and thus we will begin with our efficient code, that is the optimal code. So we are very much aware of this formula, which is n into n plus 1 by 2. This gives us the sum of n natural numbers, or sum of a particular range that begins from 0 or 1, because 0 does not really matter to us while taking out the sum, because 0 plus anything is the number itself. However, say in this case, this is the range of 0 to n, that is 5. If we plug in this into the formula, we get 5 into 6 by 2, and that is 15. However, if you notice right here, 2 is missing. We find out the sum therefore manually, because this formula cannot be used since one of our numbers is missing. We find that it's 8 and 5, that's 13. As you can see, the sum of these two numbers is 2. That is same as the number that is missing. Thus what we do in our efficient approach is we find the actual sum that is supposed to be subtracted from the sum we have right now, and this difference is returned. And I would like to now write the code right here to give you a better understanding of what we are trying to implement. So we create a variable int sum equals 0, This variable is going to be storing the sum of the array. And let's take int n equals num's size. This is so that we can write out this code much more easily of the end rather than typing out such a large function every time. Now, to find out the sum, we will have to traverse in the array. Thus, we we take up a for loop that begins from int I equals 0, goes until the end of the array with an increment of 1 every time. And the sum is the sum plus every element of the vector. Then we create another variable actual that is going to be storing the value of the actual sum, and that is by the formula n into n plus 1 by 2. We have put up this bracket parentheses so that we can first compute this, then this, and the whole then gets divided by 2. That is just to follow the rules of mathematics and make it a much more easier calculation. Now we return actual minus what sum we had stored, and just like that our efficient approach is also done. So this is our question. As we can see, Leetcode number question 268, and the question states the array, and we have to find the missing array in the range of the given array. So this is a brute force solution where we create another array. This is not mandatory, but it is often asked to not change or alter the given data set that was originally given. Thus we are creating a new array, vector array, and that is equated to the given initial vector. Now we are sorting it, the data set that we have recently created, and then a for loop is run to traverse in the range and compare each and every element with the array. As soon as we find element that is not present according to the range, it is returned. And let's say everything is given, for example, in cases like this where 0 and 1, however the range is 2 and this 2 is to be printed. We give the last element, that is the size. As you can see, we have run the test case and it is working perfectly fine, and we go ahead and submit this and it is accepted. However, you can see there is much more optimal solution, and this is now we'll go ahead towards our optimal solution. So going ahead towards our optimal solution is where we create an variable int sum equals 0. Our sum is going to be into the formula n into this is our formula that is going to be used, and n is going to be the size of the array, because writing it multiple times is going to be hard, so we'll rather take the size of the given vector. Now we have to calculate the sum of the nums array that is used, for example this, and since these have a missing element we cannot directly use this formula, rather we have to traverse in the given array. Thus we'll require a for loop. So now this is the sum of the elements of the array. This is going to be the sum of the range or the actual sum, and now we are supposed to return the missing element. Thus we do return sum 1 minus sum, and let's go for the test cases. Oh, there's an. Oh, sorry, I missed the parentheses. Please do look over this. Um, it's twice the same state. Let me confirm once. Everything else looks good to go. Oh my goodness. This is something I missed. Okay, finally we do realize the logic's fine. Let's go ahead and submit. Everything runs fine and we are with the majority.